Good evening, Regents Physics. This is I, Senor Morales. I'm here to go over some review in anticipation in advance of your exam this coming Tuesday on projectile motion. So the first half we're going to review horizontal projectile motion, and then second half we're going to do projectile motion and angle. I'm trying to shoot for a 10 to 15 minute video, no more than 15. I'll try to do my best. I'm not going to go through all the problems because some of them, hint, I'll save for your actual exam on Tuesday. So I'm working from the Unit 3 packet, which is the projectile motion packet. Unit 1 was modern physics, Unit 2 was kinematics, Unit 3 is projectile motion. The next one you have coming up is Unit 4, which is the unit on forces. That'll be coming up soon. And so we're really starting, if I'm looking at it, I want to say page 7, which is the problems working on horizontal projectiles, and that's horizontally launched projectiles. So some of the questions, on question 1 says, why is an object dropped from a height of 100 meters at the same time the object generally fired horizontally from the same height? So it's 100 meters. Why is an object dropped straight down going to versus the object fired straight out? Why are they both going to hit at the same time? But this is one of those key facts of the review question. They're going to hit at the same time because this motion, which is this initial velocity in the x, does not matter. The time to fall is entirely dependent on the y-axis. In this case, if you look at both these objects, whether I just let it drop from this height or I'm shooting it out, both of them in respect to the y, both of them have the same vi in the y, which is 0 meters per second. So because they both fall at the same height, they both have the initial same velocity in the y, they both have the same acceleration, in the y, which is negative 9.8 meters per second, then they're both going to hit the ground at the same time. And so 2 is a great review question. Once again, I mean, they're just asking you what are the horizontal and vertical components of velocity and acceleration. And so this is where we always come to our quote-unquote T-chart. X versus y, well, we know that there's no acceleration in the x for projectile motion. It's 0 meters per second. And of course, there is acceleration in the y, negative 9.8 meters per second. And this is entirely for horizontally launched projectiles. Okay, so just keep that in mind. These are objects that are fired straight out horizontally. And so if you're fired out straight horizontally, your velocity initial in the y is going to equal 0 meters per second. Of course, your v initial in the x is going to equal your v final in the x because your acceleration is 0, nothing's going to change. And so these are your initial velocities and your accelerations in the x and y, depending on that. Okay. So 3 assumes that how far from the point of release will the stack travel when it struck the ground? So this is a classic problem where we're having like an airplane flying forward. This airplane is flying forward at 60 meters per second. That's your v initial in the x, which is going to be your v final in the x. But the object is going to be dropped and it's going to fall forward because it still has an initial forward velocity. It's going to be going with the plane and then falling now, since now the force of gravity is taking over. And so, of course, over here, your VIY equals 0 meters per second. And then we're going to figure out how far we fall. And so, how far we're falling, your displacement in the y is going to be a negative 300 meters, according to the problem. And so, it could be a two-step problem. It has to be a two-step problem because the first thing I find out is how long does it take it to fall to the ground. Once I find t, Then I can plug in t into dx equals vx times t. There is no plus 1/2 at squared because, once again, like all our horizontal x problems, there's no acceleration in the x. That portion that is just going to drop off, the plus 1/2 at squared. And so how do I find t? Well, then I got to use the d equals vit plus 1/2 at squared. I'll curl out the t so I can differentiate from the plus sign. My displacement falling is a negative 300 meters. My initial velocity in the y, since this is the y-axis, time is always dependent on the y-axis. So I'm going to put time here, time to fall. My initial velocity in the y is always going to be 0 on these horizontally launched projectiles. And so this term drops out, so now I just get a negative 9.8 meters per second divided by 2, that's the 1/2 times a, and then multiplied by t squared. So really this becomes, if I drew this out, it's negative 300, dropping the units now, equals a negative 4.9 times t squared. Okay, so then I take the negative 300 divided by the negative 4.9, I get a 61.22, but then I notice that that's t squared, so I got square root. Here's a quick trick. I'm going to square root my previous answer, and so square root of that is about 7.8, so it's about 7.8 seconds to fall. That's exactly what I can fall into here, and I know the velocity of the plane is a 60 meters per second times that 7.8 seconds. And how far away after it was dropped does it fall? Well, let's figure that out. I'm going to take this answer and I'll multiply it by 60, 469.5. So for about 469. I can't round to 470 because of the 0.4. Sorry, I don't know if you can see the calculator there. 469.4. So I'm going to round that to 469. So it's going to be equal about 469 meters. And this is the main crux of the problem. Whether you're falling off a cliff or you're shooting something out, if you're shooting it horizontally, I mean, solve for time if you know the height. Then you can figure out how far away it's going to fall by using the time it takes it to fall. It's essentially this page 7. So I leave number 4 entirely up to you. Because it says, what's the initial vertical velocity of the book? Initial vertical. Vertical is which axis? I'm not even going to tell you. You should know this by now. Is it the x or is it the y? Hint, 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 hint. Number 5 in this page, and so we'll move on to page 8. Number 5 says, a ball is thrown horizontally from the top of the building with initial velocity of 15 meters per second. At the same instant, the second ball is dropped from the top of the building. These two balls have the same, well, they're not going to have the same paths. Are they the same final velocity? The initial horizontal velocity or the initial vertical velocity? Like, these questions are classic Regents problems questions, so you got to be able to do that number 5 on your own. I can't give you the answer for that as well. Number 6, you take a running horizontal leap off a high diving platform. You're running at 2.8 meters per second, hit the water 2.6 seconds later. How high was the platform? This is beautiful because this is the other type of problem that you may give. And instead of like the actual displacement in the y, they give you the time in the y. And so if we think about it, I mean, the x and y, ax equals 0, your vix equals 2.8 meters per second, so 0.8. Your ay equals a negative 9.8 meters per second. Your vi in the y is also 0 meters per second. And now they give you the time to fall. The time to fall is 2.60 seconds later. Okay, you don't know your displacement in the y, and that's actually what this problem is asking for. How high was the platform? Well, let's think about it. If you hit 2.06 seconds later, you have t, you want d, then the equation that involves this displacement and time is your displacement equals vit plus 1/2 at squared. But of course, since we're in the y, because this is dy, we're trying to figure out, then all these things apply. This drops out. So then you get 1/2 times a negative 9.8 meters per second times a 2.60 seconds squared. And let's go ahead and calculate this real quick. 0.5, which is 1/2, times a negative 9.8 times, I'm going to put this in parentheses, 2.6 squared. Well, you fell about 33 meters in the Y. Done. What's the vertical speed right before you hit the water? Vertical speed. Vertical which axis? Vertical, up and down. Vertical, vertical, vertical. That's the Y. So then that's the portion. So this was A. B's actually, what is your final velocity in the Y? What's the final vertical velocity in the Y? What's the vertical speed right before you hit the water? Like, as you were falling and you're experiencing acceleration due to gravity, how long did you fall for? How did it change your velocity? And so, your initial velocity, the velocity you start at, was 0. We know that your velocity has to change because, I mean, you're moving. There's no force of gravity when you leave that platform, that diving board, then you're just going to stay there. Your velocity is not going to change. There's no force acting on you. There's nothing changing your initial frame. So, but that's not true. We actually have the gravitational, I mean the force of gravity, the gravitational attraction between the mass of the planet and all of the objects in you. And so, you're going to have a negative 9.8 meters per second. How long you're falling for is 2.60 seconds. It's not squared in this equation. Make sure you check this form of this, and then we're going to really get to what that final velocity is right before you hit the water. I mean, of course, when you hit the water, your velocity is 0. We're not talking this is right before you hit the water. You're going to jump off this diving platform. You're going to fall for the 2.6 seconds. And, ooh, wow. And I mean, neglecting friction, it's about 25.4 meters per second. I mean, I really should keep it to 2 sig figs. So I'm going to put that to about negative 25 meters per second. I mean, 2 sig figs. That's your BF in the Y right before you hit the water. How far away from the platform did you land? Once again, how far away, change color here to note a different color. How far away is going to be C. How far away? That's in the x-axis. How far away as you're jumping off this diving platform? You jumped out this way. I mean, that's a horrible dive. You should really go up and down, but this person just went straight horizontal at 2.8 meters per second. It take you 2.6 seconds to fall. You fell 33 meters. That's like how far it is to the water. Let's see how far out into the water. Well, then once again, you use the same displacement equation. D equals VIT plus 1/2 AT squared. But since you're in the x-axis and we go back to our chart, there's no acceleration in the x. This term drops out. Then you get displacement equals VIX times T. So your VIX initially from the problem is 2.8 meters per second. The time that you're falling for is 2.6. So if I do that, 2.6 times 2.8, 7.28 meters. That's how far away from the diving board you landed. Okay? And there we go, we're at 13, we're about 13 minutes. So, vector components on page 8. You gotta be able to do that. Calculate your x and y components. If you're given, I mean, I can initially give you your first, and so this is part 2, which is your vector components. I mean, they're initially giving you like your velocity is 30 meters per second. They're giving you it's fired at 60 degrees from the horizontal. So really you're looking at what is my Vx component, what's my Vy component, and of course these are right from your reference table. They follow the format of, they use A in the reference table because A is just like a variable to represent anything and everything, but you know in this case you can use to represent velocity. Vy was the sine of the theta, Vx equals the resultant times cosine of theta, where this equals V, this is equaling theta. And so you have to plug it properly there. Number 2 is interesting because instead of giving you your x and y, giving you a resultant, they give you the x and y. They tell you that the horizontal velocity x equals 8 meters per second, the vertical velocity, which is y, equals 4 meters per second. And now they're going to ask you to calculate the actual. So this goes a little bit backwards. You're using Pythagorean theorem to calculate your v resultant. And they also want the angle. And so in this case, since you're given Vy and Vx, I would use the tangent TOA equals opposite, which is Vy over Vx. If I know that, then I know theta is going to be the inverse tangent of that ratio, Vy over Vx, and that angle is going to be tangent -1, the Vy being 4 meters per second, the Vx being 8 meters per second. So really your angle is going to equal negative tangent of 0.5, since the units cancel out. Sorry, I just realized you couldn't see that. Someone got a little excited and write a little bit too fast. So once again, we got to remember, how do we use inverse trig functions? Essentially, you're going to get the same answer whether you use inverse tangent or you use, once you solve for VR, if you use inverse sine, which is Vy over Vr, you use inverse cosine, which is cosine -1, which will be Vx over Vr. You can use any inverse, but you have the same answer, and that's a great way to check your work actually doing the other form. So like this is going to be sine -1 of Vy over Vr. Theta is going to equal cosine -1 of Vx over Vr. Like check your math and see, do these other formats and these different ratios inside the inverse trig functions match what comes out here? Okay, that's page 8. And so I'll give you a couple more problems, 3 and 4. I'll let you do that at your own. I got 17 minutes, so I got about 3 minutes left on this 20. I'm putting it at 20 minutes. I said it was gonna be 15, but let's see if I can get one good problem in, and then leave you to do the rest on your own as you study for your exam this coming Tuesday. And so this last part is projectiles at an angle, which is page 9. Page 9 and 10 are giving you some things, and so some problems, not some things, some actual practice problems to work on. And so if we look at 3, these are projectiles at angles, meaning the main thing in this case is your initial velocity and the y is no longer 0. That's the main difference with these types of problems. On the horizontally launch, you're just shooting straight out in the x-axis, straight out horizontally. This one, you're shooting it out and up. So you can see, just from that little practice before, if I'm shooting things up and out at an angle, if this is Vr and this is theta, then I do have a Vx, an x component velocity. I do have a y component velocity. The y is what actually, I need to have a y because I'm sending it up initially. I'm not just going to let it like go out and it's just going to start falling. These objects don't fall at all. They go up, and then the force of gravity slows them down, and they eventually start falling back down to the earth. And so in this case, I'm going to use problem number 1. This is going to be the one that I'm going to do as good practice. Your initial resultant is, your angle, they said, was going to be equal to 45 degrees. The ball has an initial vertical velocity of 9. Initial vertical velocity 9 meters per second. Initial horizontal velocity of 9 meters per second. The ball reaches the max height after 0.92 seconds after its launch. So I have x and y components. Nothing. This ax equals 0 meters per second AY is still going to equal a negative 9.8 meters per second. But now I have a V initial in the X, which equals 9 meters per second. I have a V initial in the Y, which is going to equal 9 meters per second. And now my time it takes from a total flight, what is that, total flight? The time till max. So right, the time it takes to max is 0.92 seconds. Well, I know the time total, if that's just halfway there, I take 0.92. I know this is sad, I'm using a calculator. I think it's 1.84. Ooh, 1.84 seconds. Total flight. And also know my velocity at max height equals 0 meters per second. Oh, and I also know in the y my velocity final, if it was shot up with a positive 9 meters per second, when it comes back down to the ground after reaching, that is going to be a negative 9 meters per second. Of course, this is going to be 0 meters per second at the max height, so it's like if you're shooting it out. And now this is entirely just considering the y components of my velocity. I shot it out, its max height reaches 0, and then it comes back down. It's going to be negative 9, equal in magnitude but opposite in direction. And so a couple things with projectile motion at an angle that you always need to remember and apply is that you do know the connection between your initial y velocity and your final y velocity, which is negative 9 meters per second. These two, you got to make the connection on your own. You do know the velocity at the max. And of course, sometimes we have to calculate time, sometimes time is given. In this case, time is given. Determine the total speed of the balls that leave its launcher. That's going to use Pythagorean theorem. They want you to calculate the actual resultant velocity. So c squared equals a squared plus b squared. Since I know that both of these are 9, I'm going to just plug it in. It's going to be the square root of a squared plus b squared, which is going to be 81 plus 81. My resultant velocity is going to be a 12.7 meters per second in this case. That's my speed as it leaves the launcher. Determine the horizontal distance traveled by the ball during the entire time it's in the air. That's why this was only time till max height. That's half flight time. This is full flight time, 1.84 seconds. I'm going to, this is part B here, and calculate this out. I'm going to make sure you can see some of these problems here. So this is part B. Well, the horizontal distance is dx equals vit plus 1/2 at squared. And of course, oh, guess what? My a and the x is 0, ladies and gentlemen. Like, x is really boring. You should start seeing a pattern here. It says literally, this goes into your notes. The only equation we ever use for the x in projectile motion is dx equals vi times t. That's it. The test becomes much more easier if you memorize this fact, but we can always get to it by using the full equation and writing out our t-chart for x versus y. And so dx equals vi, and the x, which is 9 meters per second, times my total flight time, which is 1.84. I gotta think about, am I only considering how far I wanted to go halfway or how far I wanted to go the full? And in this one it says the horizontal surface traveled by the entire time it's in the air. 9 times 1.84 equals a 16.56 meters. Not bad for a tennis ball launcher. 16 meters. Now determine the max height of the projectile. This is entirely different because now we're going to consider the y-axis. I'm considering the y-axis in this case. And so all these other things come into play. Can I zoom out? Oh, I can zoom out. Amazing. So now I'm going to use entirely the y side of things to figure this out. I'm going to use the same equation, dy equals vit plus 1/2 at squared. But remember, they wanted me to go to the max height, which happens in the halfway path. So should I use the half time or the full time, ladies and gentlemen? What do you think? If I want to find the distance to the max height, which time should I use? The video has not frozen. I'm just giving you some time to think and say out loud. I hope that you've said, we remember in Blue's Clues, right? What do you guys think it is? Half time or full time? I know this is the max height. This is not time max total. This is the half time versus the full time. Okay, you want me to move on? You should have identified this one. I know you guys are smart, so I'm just assuming at home you got that one correct on your own. And so, is my initial velocity 0 in this case? Is my initial velocity in the y 0 like it's always been? Is it, guys? What do you guys think at home? No, it's not. You're right. Absolutely right. I hope you're right. We have initial y. I just did a whole spiel at the beginning of this about that. So I'm going to do this positive 9 meters per second times my half time, which is 0.92 seconds, plus 1/2 times a negative 9.8 meters per second. You guys better start respecting this rogue negative here. It'll ruin your life if you don't pay attention to when it needs to be negative. And now the half time is 0.92 seconds squared. And so I substitute with units, so I'm just drop units out. It's going to be 9 times 0.92 plus 8.5 times a negative 9.8 times 8.92 squared. Let me show you how I plug this into my calculator. If you can see it from here, I just do it as is. 9 times 0.92 parentheses plus another parentheses 0.5 times a negative 9.8 times 0.92 squared, close up parentheses, and I get, sadly this ball only goes 4.1 meters in the vertical, in the y-axis. That's the max height. What more can I say? What more can I say? And D, compare the vertical acceleration of the ball at the time the vertical acceleration of the ball elapsed. Look, vertical acceleration. Why are we comparing the vertical acceleration? Vertical acceleration. What is vertical? Is vertical x or vertical the y? You're right. It is the y. It's the vertical is in the y, and so. Is my acceleration, is gravity changing? Do I experience a different force? Am I falling at a certain rate when I start and then falling at a different rate later on? That makes no sense. No, we're experiencing the same force of gravity throughout your entire flight, so the acceleration doesn't change. So this question is a moot point, but they do ask it all the time. So the answer to D is C. It's the same. It is the same. Okay, and so question 2 and 3 I leave to do for you to do at your own. You really have to find out these things, and maybe I'll post a video if you guys ask, but we are going over this tomorrow in class Monday, and your test is Tuesday. But you can see it's just, am I plugging in the correct things that I'm pulling from the problem? And the only other thing is, like, sometimes they might give you the actual resultant velocity, and then you have to figure out the components, Vx and Vy, and then it's boom, it's just clockwork. Sometimes they don't give you T. Oh, what do I do if I don't give you T? Well, I guess I might as well hit the 30 mark. 27 and a half minutes in, people. But let me just go you. So number 2, because I just want you guys to understand that you can do this. So this is going to be 300 meters per second. Here's your Vx. Here's your Vy. And so your angle is 30 degrees. And so if I want to find the time it takes to reach the max height, or the time it takes to reach the full height, with time, once again, time is in which axis? The horizontal or in the vertical? Which one does it depend on? You guys are making me proud out there. You're right, it does depend on the y entirely, on the y-axis. So I'm just going to calculate the y component here. I'm going to do my Vy equals my V times sine of theta, which is going to be 300 meters per second times sine of this angle, which is 30 degrees. And I know that sine of 30 degrees equals 0.5, so I have 300, so Vy is going to equal 150 meters per second. Don't believe me? Then do it on your calculator. Okay? I'm almost tempted to, but I'm absolutely sure that I'm right on this. And so Vy equals 150 meters per second. That's the initial vertical component. So determine the max height. Well, and determine horizontal range. I always suggest solving for T. So if you want to solve for the max height, think about it. You're going to start out with a positive 150 meters per second. And remember, you need just the y component. Some people make the mistake of using 300 as their initial y, but no, that's x and y. You just want it there. At the end, it's going to be a negative 150 meters per second, and always that V max is going to be 0 meters per second. And so what's the time it takes to go to a halfway point, 0? Well, let's think about this equation. Vf equals Vi plus A times T. Where my final velocity that I'm interested in is 0. When did it get to 0? Well, that's at the max height. Over here, I have a positive 150 meters per second, which was my initial, plus that negative 9.8 meters per second, And then now this is the t I want to solve for. Oh, so let me see this. 0 equals 150 minus 9.8 times t. Negative 150 equals a negative 9.8 times t. I do a negative 150 divided by a negative 9.8. I get, my time is going to equal a positive 15.3 seconds. About rounded. That's how long it takes to get to the max height. Am I done yet? No, I'm not done. Why am I not done? Because they didn't want the time it takes. But I need the time to find the max height, because the next equation is going to be distance in the y. Distance in the y equals vi times t plus 1/2 at squared. Okay, and I'm so sorry I didn't model what we should be doing, so I'm gonna do it over here in blue, so hopefully blue stands out versus the purple. No, actually I'll do it in orange. I think orange will be better. Oh, over 30. Oh, fast forward and rewind to this video as needed. X, Y. I'm in the Y, so I'm gonna worry about the Y. So what's my acceleration on the Y? My acceleration Y is a negative 9.8 meters per second per second. What's my initial velocity in the Y? My initial velocity in the Y was 150 meters per second. What's my time to the max height? What time was 15.3 seconds. And I see, I want to lay those out because those are the things inside what I'm going to plug into, so I know. Well, let me go back to red, see a little bit better. dy is going to equal that initial velocity, 150 meters per second, times my time of 15.3 seconds, plus 1/2 times the negative 9.8 meters per second times that 15.3 seconds squared. And so I need to substitute with units, so then I can rewrite it like 150 times 15.3 plus 0.5 times the negative 9.8 times 15.3 squared. Because it's really like two sets of multiplication being done, and then we're going to add them both together. So let's figure out how high this ball goes into the air. 150 times 15.3 plus 0.5 times a negative 9.8, and you're going to realize, like, you're going to see this a lot. 1/2 times 9.8, 1/2 times 9.8, it's always going to be a negative 4.9. But I'm just doing the full version so you guys get the hang of it and see that pattern. Whoa, what is this? Oh, missile. This makes sense. We're shooting a damn missile. I should have read the problem. I'm like, what the hell? It shoots pretty high. So yeah, you're going to have your distance in the y be about 1148 if I round to whole integer meters. If I really want to do justice to it, then I see like 9.8s are limiting, but it's really 9.81. If I really did this as 3 sig figs, then it's going to be about 1150. 1, 2, 3 sig figs. The trailing zero is not significant meters. Okay. So that's your classic problem. I leave it to you to figure out number 3 with Peyton Manning. Oh, I'm sorry, I spelled Peyton wrong. It's P-E-Y, not P-A-Y. P-A-Y, pay? No, Peyton, P-E-Y-T-O-N. Please correct that in your packets. That's, I guess I put Peyton Manning. Dang, it must have been really late. I'm sorry, I apologize for that. But do try number 3 on your own. On page 11, I am going to use those questions for free response questions on your exam on Tuesday. So page 11 I'm not doing. I leave that to you. And tomorrow in class I'm going to go over the multiple choice which ensues and follows. So this packet is one and done. Ladies and gentlemen, have a good night. I hope you watch this video and eat on out shortly. And we'll see you tomorrow. Thank you and good night.